Alright, what's up guys? Back again with another algae stream. So today we're going to get back into our to-do driven development and try to address some of the stuff we logged as to-dos yesterday. So actually I guess since yesterday my priorities have changed a little bit, and I'm not that worried about the prompt. I'm more worried about this stuff. So panicked and not yet implemented. However, another issue here is that the last, so okay, I guess I should say what I'm doing here. So Ivy comes with this file called demo.ivy. This is what you step through when you run Ivy and you run the demo command. So this is what gets stepped through just to show off all the features of Ivy. So we successfully handle the first few commands. We can do 2 plus 2. We can do a number. We can add different numbers. We can multiply, and we can subtract. And you'll see that here. We do get this minus 22. So this is the last line that we can handle successfully. Now, not only can we not do exponentiation, but it triggers this to do. So it's trying to parse something as a variable. Yeah. So something's going very wrong here. Let's see, if we do cargo run, something I was curious about last night is, can we do like compound expressions? We can. That's pretty exciting. Times 3. So I think this might be straight. Yeah, this is a similar example to this. And actually, I have it backwards. If we do 2 times 3 plus 4, so it should do, yeah, 3 plus 4 first is 7 times 2, 14. Okay, so we can actually do compound expressions. That's pretty cool. But we need to figure out this exponentiation thing. Great. Okay. So let's try running this with the backtrace, just to see where it's all going wrong. So of course this is the last place, but it's not a variable. For some reason we should be, yeah, for some, I don't know why that doesn't work. Okay, so we parse a line, it calls expressionlist. We might end up writing some real tests today. Okay, expressionlist, statement list. Okay, statement list, exper, so I guess that's here. 220. Operand, oh, okay, operand. Wait, let's look at, I'm just a little confused about these line numbers. Okay, number or vector. Okay, 311. Next, oh no, this is 311, self.number. Okay, the value is a string. So let's just debug self and toke here. And something doesn't implement debug. Oh, the parser of course doesn't implement debug. So let's just see what the token we're trying to parse as a number is. Let's go to the end. Token. Text is empty. 7. Okay, let's go back to the demo. Okay, so it's supposed to be 7 exponent 3. What if we don't put spaces? Identifier. Okay, so something's going wrong when we do the star. Okay, so we need to go back up a little. So it's not number. If the value is a string. Okay, so where do we assign the type is the big thing. For some reason, the type is getting assigned identifier. Okay, so that's what we should look for. Okay, so where does this token come from? So we come into number from number or vector. So the token is already passed into here. So I think we should look at operand. And the token's passed in here as well. So yeah, I think this is where we're getting token identifier. So the issue must be before operand. So let's look at exper. Now this returns an expression which okay, hold on. Exper operand. Operand gets called here with a token. Okay, so for some reason, yeah, let's debug this token here. Token number. What? Oh. So it seems like, so here's our 7. Where did I just put that debug? Okay, so this never returns. Okay, so something happens in here. Wait, really? Token. 7. Parser self.next. So I can't debug this token. Weird. Let's go look at our parser. Scanner, tokens. Maybe we should debug self.tokens. Let's try that. Tokens. Yeah, okay, so the tokens have already been decided, basically. We've got this 14. Okay, so I guess we do need to go back up from exper. So we're already having trouble in exper. So I think we need to look at statement list. Okay. And so this is calling. Let's try self.tokens here. Okay, so for some reason, our star, where do we turn things into tokens? I guess is the question. Statement list. Alright, we're already in trouble here. Statement list, expression list. Okay. Let's debug it here. Whoops. Okay. 14. Okay. Already in trouble here. Expression list, line. It seems like we're actually having trouble when we grab the line. Is that right? Vec expression. So inside of line we call expression list. So for some reason, our token here is not being identified as an operator. So we should get number. Let's see. So we get a number 7. Fine, no problem. Okay, it's supposed to be expressionlist. Tokens. Seven, nothing, 3. Okay, so something's obviously wrong before line even. I guess it's in run, maybe. If not, self.read tokens to new line. Let's look at this. Tokens.clear. It looks like for some reason we're just not yeah, so we get the 7, nothing. There's nothing in the text. And it calls it an identifier. So when we do the other ones, maybe this is just getting parsed completely wrong. New line, new line, new line. New line, new line, new line. Number. Operator. Okay, so when we do plus, it is getting identified as an operator. New line. We get a number, operator. Okay, so why is plus an operator? Maybe we need to look in next token. Token new. State.run self. If state is none, return self.token. Is operator. Oh! This is the issue right here. Is operator. This is wrong for some reason. Okay, so this is our multiplication, I think. Demo.iv. 2345. Great. Starts with star. Now this one starts with star as well. Oh, it prints it twice. Okay, this doesn't look right at all. So let's go take a look at the Go version of is operator. What is this? Oh, right. Is operator. Okay. Yep, no follow-up. L.next. I think we're calling the wrong next, potentially. Let's go look at next. And let's look at our next token. Yep. Definitely not the right next. So this is just supposed to be... what is L here? L is a scanner. So this should be self dot... Whoops. Next inner, I think. Yes. Okay, these should all be next inner. I think. Let's make sure they all should be that. Next, 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 next. Next. Enter. Okay, let's try that. Alright, Stack Overflow. That is probably fine. Debug. Okay. Let's see how far we make it now. So we get, let's see, minus 22, 343, that's 7 cubed. Okay, now we're crashing here. Alright, so we'll log that. Oh, I never pushed these from yesterday. Okay, so we fixed scanner dot is operator. Great. So now main has overflowed its stack. Demo IV. Now we're trying to do 7 mod 3. Okay, and that's because we never actually installed the binary ops. We never actually installed mod as a like the word mod as an operator. We only did the %. So we're looking for mod Euclidean integer modulus. I'm not really sure what the difference is between this binary big int op. Euclidean. Yeah. If anybody watching this really wants to do some simple open source contribution, I think you could make a pretty substantial PR just fixing all the typos in Ivy. And also doing stuff like just following the linter, right? Like this can be that, because you don't actually use the context. You could reorder all of their struct fields to save a bunch of size. Let's look at a struct, for example. Pretty much all the structs are like this. Oh, maybe not this one, actually. Let's look. This one? Struct. Oh, this is because I keep going to the same one. Let's try this one. Yeah, so this, you could save 8 bytes right here. Struct with 112 pointer bytes could be 104. So you could do stuff like that. Anyway, I guess for now, let's go back to our binary. We will just make mod an alias for the other mod. Okay, that's not ideal. So we must be parsing it wrong again. How do they make this work? Is operator. Well, the issue now is we're not even getting a stack trace. So let's go back through this again. Scan. So we should be getting an operator. Well, where do they actually check for mod? So it seems we're recursing infinitely here. We're recursing infinitely, and I don't know where. This would be a really nice time to finish dev. Let's see. let's try using the debugger. Alright, so we're going to run this on demo. Okay, so we're going to try running this on demo.ivy. Alright, segfault. Break mean. Great. Alright, step. Ooh. Oh, great. It's fine. Alright, hold on. Next. Alright, let's just... Okay. Let's go to run. Yeah, I always have a hard time using the debugger. I love using GDB for Fortran, for example. Let's try break run. And let's run this. Alright. Continue. Okay, great. Now let's try stepping. Print. We go to prompt. Okay, just forget it. Okay, we finished prompt. We're back in run. Or, oh, we're in Lex run. Okay, Lex any. Okay, I think I need, let's just kill this for a second. Because we need to go to demo.ivy. We're having trouble with this line right here. So let's open temp/try.ivy. And we'll just put the one line that we're having trouble with in here. So let's try running this with temp/try.ivy. Next. Alright, we're in run. Okay. Lex any, fallthrough is none. Complex. So at some point, number. God. This is the issue with using GDB. God. I mean, it's so... Okay, anyway, it's a number. Pushing. We're trying to get another token. I guess it's a space. Okay, so we just got the space. That's good. We're in space. Alright, fine. State run. We're back in any. We're falling through. State is none. State run. Match self. Okay, we're supposedly in an identifier. Next token. C is 109. Okay. Whoops, let's try this. Is that not how you do it? this is 97. Okay, so we're 12 past that. That feels like M, is that right? 97. B, C, D, E, F, G, H, I, J, K, L, M. 12, yes. So we're in the M right now. So we should be finding... We're just trying to figure out why this isn't working. What is our mod getting read as? I guess it's an identifier? I guess it should probably get parsed as an identifier, and then it should get looked up in our... We should try, it should be like parsed from a string. Maybe it's supposed to be parsed as an operator. Maybe that's the problem. Certainly looks like it should be parsed as an operator. Oh, right. Is this not... Let's go look at the regular mod. I'm somewhat inclined to just delete these lines from the... oh, what? Name mod. Oh. This one. Oh, iMod. Yeah, what I was saying is that I'm kind of leaning towards just deleting this line. Because I still don't really see the difference between this mod and the other mod. Euclidean integer modulus. Big int. Oh, this is the remainder. Truncated modulus. And this is the modulus. Euclidean modulus. Yes. Well, regardless of what the operation is, we should be able to handle it. Identifier. I saw identifier for a second. What are we in here? X token. Fallthrough. Alright, I think we're gonna quit this and just go back to this. Thread main is overflowed stack. So let's go back to parse. And let's try to see. This is pretty rough. I'm not really sure where this is happening. Function definition. So somewhere we're supposed to be. Let's try this. Oh, right, it just crashes. Oh boy. Okay, expression list. Alright, let's just go to run. So we go to run. Context, eval expressions. Alright, so I guess we're going to be in self.line. Read tokens to new line. Let's see what we return. Nope. Alright, that didn't help. It must be happening in here, maybe? No. Whoa. Okay, so it must be before peak. Demo.ivy. 7 mod 3. Okay, so it's before peak. Current line in line. Alright, we're in line. We're recursing somewhere in here, I think. Oh, wait, we never go into new. Alright, inline, returning error from line. No, okay, we don't return. So we're in here, peak. But we don't end up in here for some reason. Inline. Line. Oh, I bet it's in here. In read tokens to new line. Okay, yeah. Cleared tokens. Okay. Making some progress. 15, 7. Okay, so we get a 7. That's right. Oh. Okay, we don't hit EOF. So the type here is number. Okay, so we do nothing. Tokens.push token.clone. Okay. Print line, finishing loop. So we finish the loop once. We go back to next token. I bet it's right here, isn't it? Yeah. Okay. So why does this keep getting called? I guess it's right here, maybe? State run. starting loop, in next token. Starting loop, in next token. So we go through twice. Whoops. I wonder if it's this self thing. Stupid. Ooh. Is it this? Read OK. Last rune. Last width. Token EOF. L.pause EOF. Lex any. State equals state.run. Self. If state is nil, return l.token. Oh, wait, but it keeps calling itself, I think. Ah, okay, let's go down to run. We're calling next token somewhere in here. Yes, okay, it looks like I missed one, maybe. Lex space. This is supposed to be next inner. Lex identifier is supposed to be next inner at terminator next inner. Yes. Okay. So for some reason I just got hooked on typing next token. This is probably, okay, is Lex operator. Yeah, these are just all supposed to be next inner. I think I really messed up these fall throughs as well. Back up. Yeah. Oh wow, I totally messed this up. Because the fall through, I was thinking that the fall through took you back out to the conditions, but it literally just falls through to the next case. Back up, return complex. Yeah, if an operator, which an identifier and index expression, otherwise it could be a signed number. Yeah, so this, okay. So wherever I call this, should just be, this is in minus, yeah, this or this. This just falls through. Let's just inline this. Oh boy. Alright, hold on. Let's try this. Did it work? Bad character. Alright, we gotta go take this stuff back out. Finishing loop. Clear tokens. Debug. Whoops. Okay, right here. Bad character, sum 32. What? Type error. Sum 32. Let's really debug that token. Error 2. Text is bad character. Oh boy. Alright, so clearly something's going wrong here. Maybe we should debug state. Maybe it doesn't implement debug. State. Lex. Derive. Okay, state none. Sum 32. Bad character. At Terminator. What is character 32? Is that a space? Decimal 32. You're kidding me. Where's 32? Oh, it must be a printable character. What? 32. Oh. .32 is a space, yeah. Okay. State none. Bad character. Identifier. Debug. L dot. Token. EOF. Okay, so we found an EOF when we were still expecting an identifier, I guess. Complex non-space any identifier. Oh, man. Next token. I guess we're just gonna have to keep we'll just have to keep going back the same way every time. Okay, we got a bad character. 343. So this works. We get 7. That's good. And then we try to read mod, and it just doesn't work. So it seems like our named... It seems like our named binary operators just don't work. So read OK is true, last char none, last width 0, token, we've got a new token. Oh, it seems like we're just not even, okay, we better go to lex any. So run, let's look at any. We can debug l.token. Okay, so it's supposed to be EOF when we come in. Let's go look at lex any, I guess. All right. We're supposed to call this next. All right, I better just move this to the other one. This is going to drive me crazy. It keeps selecting this. All right, let's see if I can open the chat on my phone, maybe. All right, I open the chat on my phone. Whoa. I hate this phone. All right, I'm just gonna plug in the phone and look at chat that way, because this little pop-out thing is driving me insane. All right, let's get back to business. So we are in lex any. We are supposed to look at l.next, which looks like this. Okay, that's the right thing. Okay, so, okay, we return, this is the EOF case, return nil. Oh, is that the issue right here? Next inner. This might be the issue right here. No. Okay. So it's not, whoops. It's not that. We're making it down here. Okay, we can just debug R, I think. 55, 32, 109. So 109 again is M. This is the M. What's the matter? Okay, so it's not a new line. It's not a semicolon. It's not a comment. It's not a space. It's not a backslash. Or not a quote, sorry. It's not a raw quote. It's not a sign. Okay. So, oh, okay. Alright. So, yes. Oh, yes. Alright. We're going to inline fall through. Self. Yeah, okay. Stupid. This is self. Okay. Yeah, I really messed this one up. So where does it say fall through? We're just gonna fix all of this. Okay. So what we were supposed to do, minus plus, we go in here. If start greater than 0, we do all of this. Otherwise, we fall through, which means we run l.backup, and we return lex complex. That's all the fall through means. Okay. Okay, be this or this. Okay. So these all return, right? Return, 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 return. Fall through to this. Okay, so we can actually just inline this here. So now if R is period or this, we do this. If R is an equal sign, then we peek. We peek. It looks like I got this backwards as well. if r is an equal sign, then we peek, and yeah, it looks like I got this backwards. If the next character is not another equal sign, then it's an assignment. Okay. So this should be I'm trying to think through this. So what's actually happening here, we're supposed to omit an assignment if it's not. But my issue here is that we would do this, I think, if it were none, or oh, this is a rune. Why does our peek return an option? Oh, perfect. I didn't say why. I guess it's because read rune returns an option. Yeah, none for EOF. Does Go have? Can you just have like EOF char? A rune? Is it? I don't know. Not sure. I guess we'll just do this. So this should definitely be not equal to this. Probably. Let's just do it this way. Let p be l.peek. If p is none, or let's see, if let sum c equals p, and p not equal to, and c not equal to this, or p is none. I don't think this works, but let's see. Yeah. Okay. So if it's sum and c is not equal to equals, I guess we can use let else, right? Because, I mean, EOF is not equal. I don't know. I guess this is fine for now. We'll see if it matters. This is not supposed to be next token. This is next inner. Then we need to inline this. This is supposed to be next inner, and then we fall through to is operate. That's so dumb. Like, why even bother to fall through? It's the same. You just return Lex operator. Okay. If L is operator, return Lex operator. If it's alphanumeric, back up, identifier. Then down here we'll match R again. Okay, this should all be okay, I think. Okay, so we fixed our fall through disaster. Oh no. Oh no, I think we had a regression. I think we broke something else. R is 35. Debug R. Take that off. Oh no. So now we can't even do our 2 plus 2. Cargo run 2? 2 plus 2. Wait, what? Aha. Okay. Ah, it only works with a space between it now. Okay, well clearly I messed something up with scan. Seems I probably messed up space. 35. Oh, right. Actually, let's go back to this R again. Match R. So what do we hit? 10. Line feed? Oh no. Oh, or new line? New line. Okay. That shouldn't be... Let's take this off. Debug char from R. I want to see the character. Yeah, okay, we get a new line. Well, why don't we just admit a new line? Parser expression. 2 plus... Oh, for some reason we ate the 2. Oh, I think it's because... Alright, is something wrong? It must be something wrong in next token. Okay, because I think it's putting the 2... It's like putting the 2 and the plus together, I think. Like it's like a sign. So let's see, we must have messed something up with the fall through stuff. Alright, lex any. So we either get it or it was EOF. So new line, we should come in here, right? We admit a new line. Semicolon, this should all be fine. Comments are obviously working correctly. So it's not a space, it's not a quote, raw quote. So this is where we need to look. It's an operator if it's preceded immediately by an operand. It could be assigned number. It's an operator if it's preceded immediately by an operand. Is 10. 10 is the new line. Take out last rune in string. So it's not going to be alphanumeric. I think it must be this fall through case. Let's see. Falling through. Okay. We're in start, so none of this matched. Now we're supposed to be falling through. I guess we can do the same thing here, right? Go run. In start. So it's not supposed to fall through. I think we should be, let's see, print line. So in start, ret op 1, ret op 2. Okay. So it's supposed to hit this. Let's see what RR is for them. 50. Type rune. Let's see. Print rune as string go. Oh. Okay, so for some reason we have a new line on the end of ours. Up to L.start. L.input. What is, okay. Okay, so RR ref stir, and this is supposed to be a rune. Decode last rune in string. Oh, dot unwrap. Okay. All right. Did it work? No. Oh, yes. Okay, good. Okay, we're back in business, I think. So we got 2 plus 2, 4. Excellent. Get rid of this. Okay. Turning. Where else am I printing stuff? Falling through. Okay. So we're back in business. We got 4, 23, 68, 1035, minus 22, 343. And now we are starting to parse. Actually, let's put some of this back. Yeah, so we got 7 space M, and for some reason we got bad character. Great. This is good. This is good. We made some progress. That's slightly frightening, but I think when we're in this case, we read the second star, which is why it's not printed. So we get comment, 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 comment. 2 plus 2, 4. Comments, 2. Oh, and then, so this one's 23, so it reads the next one, 23. 2 plus 4, Oh, this one's 23 plus 45. Okay, so what is happening here? Let's debug this state. Okay, supposedly we're in an identifier. So let's go look at Lex identifier. Okay. Okay. And here, C. I printed the letter C. Let's take this and we'll do char from C. Mod. Okay, this is fine. Why are we not... Okay, let's go look at Lex identifier. While... Okay. Is alphanumeric. Okay, I need to think through this again. I obviously messed it up the first time. So while the next character is alphanumeric, call next. Okay? Okay. So we look at the next character. If it is alphanumeric, call next. Loop. Okay. So we do while at sum to make sure we get a character. Okay. So we got a character. If it is, let's write it this way. If it is, if the character we peeked is alphanumeric, then we call L.next. If it's not, we break, right? Okay. Now, we're trying to parse 7 mod 3. Whoops. Run 7 mod 3. Okay, so let's go in here. Let's print line. L.token. Maybe 7 mod 3 EOF. Let's try that. 7 mod 3. That looks like MOD to me. Mod and then 1. Okay, so we are supposed to get mod. Oh. I see. I think we're supposed to call next one more time. Yeah, I think we always call it, that's what it is. That's what it is. So, while this is sum, we call L next enter. And if it's not alphanumeric, then we break, like this. So we just always call it. Okay. Identifier, any, 3. So we made it to this. Great. Let's delete in here. And debug. Let's take this one off. So we get 7 m3. Great. 7 mod 3. And we're supposed to get the new line. Okay. Now, variable. The issue, I think... Now we gotta debug this again. I'm a bit suspicious because we're not getting that space at the end. This says identifier. Oh, it says mod. Okay, it's saying identifier. This is supposed to be an operator. So this isn't being detected as an operator, which is the issue, I think. And I think it's because it ends in this space. Okay, so we slightly messed something up here. Here's alpha. Back up. Where is it? We were just here. Where's our while at? Okay, this is where we were, I think. Maybe we need to look at is alphanumeric. Is letter is digit. This doesn't seem quite right to me. So we're calling L.peak if it's sum, so not EOF in our case, and it's alphanumeric. I just don't see why this doesn't work. This looks right to me. So in this one we get the mod, but we get like one too many. See, here we don't get mod. Maybe this is like including a space or something. A to Z space assert not space is ASCII alphabetic. Okay. And this is just a digit. Is ASCII digit. Space, not space is digit. Okay. If it's not alphanumeric, break. Seven mod 3 mod, we get MOD 1. Okay, if I come over here and I debug, oh what is this supposed to return? Option U8. What? Alright. We get 109, 111, 100. That looks fine. That actually looks right. And then I should get EOF. But instead I'm getting bad character. Whoops. So I know it's alphanumeric here. MOD. And then I should get 1. Come on. Maybe this. Oh, is this the problem? Oh, it's supposed to be not at Terminator. Wait, am I dumb? Alright, I guess it's just a typo. Okay, we don't have to. I don't have to think I'm dumb. It looks like lots of stuff is working now. So let's take off. We can take all of this out. Okay. Let's take these debugs out. Whoops. I didn't save it. Let's look for another debug. Just delete that line. How does that look? Alright, we got 4. Wow, we made it a lot farther. We made it a lot farther. I think our mod might be wrong though. Let's see. Demo.iv. So, well, I guess we should look at iv.out. Demo.out. Alright, so we got 4, we got 23, we got 68, 1035, minus 22, 343, 1, 14, 32, 7, 1/3. Okay. This is great. So we made it through, what did we make it through? Okay, we got, wow, we made it through all of this. 14, 2 to the 5th, 32, 7, 1/3. Okay, so we don't know how to add rationals. Okay. Excellent. Make it through mods in demo.iv. Alright. So we just need to know how to add rationals now. Oh, I remember. Okay, let's go to expert. Actually, we need to go to value. Okay, so instead of making this like this, we are going to make a rational, a num rational 32. Okay, so we're gonna, yeah, we're gonna get rid of this constructor's macro completely. So we'll do fn. Let's see what happens. Make clippy. 2 fields. I'm sure that num implements it for us. Rational. Yeah. So we actually do want to, let's go make this constructor. So we'll have one called fn rational that takes v1 value and v2 value and returns a self. So it's going to be num rat32 from, I don't know. How do we create it from a numerator and denominator? I don't know. Is there some other way we can do it? Oh, here we go. Let's see. We better just do if let int v1. This one. This is a value for sure. Let's see. If let v1 equal v1. If let int v2 equals v2. Then we can construct this. We can return a self-rational. Otherwise, we panic. Try to make a rational from v1 and all right. Oh, great. Let's see if we can run it again. We haven't done, we have not implemented plus for rationals. If let value rational I equals left, if let value rational j equals right. (17 over 15), fantastic. Okay, what is the next thing? Okay, use num rational 32 inside value rational and use their plus. So what's next? We are now supposed to do exponentiation for rationals. Binary, okay. So it looks like, so that's int. We're really gonna have to come up with like a macro or something for this. Let's see. I'm thinking something like this, where we have like macro rules. And I'm thinking diagonal because I'm thinking about this as like a, matrix where the diagonals are the diagonal is the types are the same. So like the 0, 0 entry is int, and then you'd have like int float, int rational, and so on. So diag, it takes a type. I always put it on the wrong one. Type is like an ident, I guess. Then we'll have to have I, ident, j, ident, and then we need body. I don't know. I guess right now it's just an expression, right? So this turns into one of these. So it's if let type I, type J. We're gonna have to pass in left and right as well, I think. Left, ident, right, ident. Then maybe we just put expert here. So this will be diag of value int I, J, left, right. Yeah, we have to move it up to right here. And we need a semicolon. Does this work? There's no way this works. I guess it's not. Maybe this is the problem. Type. Let's see. Rust macro. Enum variant. Oh, I guess we can do that. For some reason, yeah, the colon is throwing it off. Oh, maybe it's because it's, I guess this is not, what did I call it? An ident. It's not an ident. It's, I think this is the one I usually look at. Lifetime. It might be TY, I guess. Is it a type? It's not really a type, maybe? What's the matter here? Expected pattern. That's kind of sad. Maybe. Let's see what we can do here. Maybe we just have to do it like this. Does that work? Alright, hold on. Oh, now we don't have I anymore. Oh, come on. Oh, now it's, hold on. Now it's not a type. Now it's, wait, what is it now? I have no idea what it is, actually. Oh, does that work? I guess we'll call it P1, P1, and this will be P2. P2 is an expression. Yep, take that out. Does that work? Oh. Okay, this doesn't work because arbitrary expressions aren't allowed. Oh, wait. Okay, this is supposed to be value int j. I feel like this should be possible. But I'm not sure. I think we were closer at the beginning. I think maybe I just had the wrong type. This is how I want it to look. And I think it's just, maybe it's just not a type. Statement, ooh, what's this? Pat. Ooh. Maybe it's a pat. Okay. Okay, let's get rid of I, maybe? Okay, that's good. Let's say P1. Now it makes sense to call it P1. P1. P2. P2 is a pat. This is barely better than before. Yeah, that's actually, it takes up even more room. Yeah, it takes up even more room. We have this repeated everywhere. What type? Yeah, I mean, it's like longer than it was before. Okay. I mean, I'll leave it for now, I guess. Yeah. So right now we're trying to do, if we have a rational on the left, this should give us a rational back. Looks like I don't need this, maybe. Okay. No, parse error. So we got 17/15ths, 1/9, 6/5. Okay. I don't know about this macro. What I really wanted, I wanted this to just say IJ. And then we could even have this. Wait, isn't this an I32? Oh, but this takes a U32. Okay. Yeah, I really wanted this to just be I and J. And then I wanted to get rid of all the instances of value int. Top level warp takes a pattern. What is this? Pat param. Oh, I bet a pat param is the thing inside. Let's keep playing with this macro. Okay, so we'll say type is a type. Ty, is that right? Ty. P1 is a pat param. P2 is a pat param. So we're trying to make type of P1. And this is supposed to be type of P2. And so now I should be able to do whoa. Expected pattern. A type path. Let's see. Task enum variant to Rust macro. I can't seem to get my macro rules to work. It is a path. Aha! Okay, that worked. Thank you. To the internet. So that's pretty neat. Okay. Value int. Maybe we can do return type of expert. Alright, that's kind of neat at least. Now can we just flatten it out? That's what I really want. It's just a little too long. Just a little too long. Let's go up to eval binary. Yeah, and then we can just use value star. I don't think anything will be ambiguous. There we go. Okay. So we can almost use this for the other one. Actually, can you do this? Maybe we can't do this. Yeah. Yeah, I think we'd have to match it as a whole pattern. Yeah, not sure. Well, anyway. Int ij. Yeah. So, yeah, what I'm thinking basically is we've got like type 1, P1, then we've got type 2, P2, then we would do type 1 here, type 2 here, and then like ret type maybe? Ret type. So this one's ret type. So we need to change the name, of course. But that, so now it would be diag of rational I, int j, left, right, rational I dot pal j. Okay, great. That's pretty nice. We just need to change the name. Because it's not just the diagonals anymore. I don't know what to call it. But this should be diag int I j left right I mod j. That's pretty nice right there. And this, yep, same here. I over j. Oh, this is nice. Can't do this and go. We could even write a macro that expanded these, because these are all the same, right? Value complex, okay, that's fine. Yeah, see, this looks the same as this, but with a minus. And plus will be the same. And now we can actually do the same for rational. Great. Okay, macros. Oh yeah. Now you see that these look the same. So yeah, we could do like all of the diagonal ones. Wow. So we want another macro. This one should actually be called diag. Let's think of another name for the other one. Let's call this like make ops. Okay, and then we can do make rules, macro rules. We'll actually call this one diag. Macro for generating ops for the types where for generating diagonal ops, i.e. ones with two of the same type. With something like that. So this is actually going to be a list of types. Actually, I guess these have to be paths. Path. And we can throw one of these in here. this just takes, yeah, it's going to call make ops with type ij left right. Ooh, can we pass in an operator? Type ident. Is plus a keyword. Probably not. A token. Ooh, maybe we can use a token. Keywords? No, it's like a symbol. Characters and strings. Literals. What is a plus sign? Suffix. Character literal. String literal. Raw string. Numbers. Punctuation. Oh. Can I match punctuation? Well, I think what we could do... We also don't know what I and J are. Yeah. I don't think this will work at all. Type. Yeah, okay, maybe this doesn't work. It looks like it should work. I just want to expand to this. We just need to plug in this and this, right? Alright, we'll put this on hold for now. Feels like we should be able to do something like that. But it's not clear to me how. Alright, so we need to look back at our parser. I guess we should commit this. Right, make ops macro and handle more combinations, I think. Or maybe we just handled one more, but we did something like that. Alright, we are failing to parse 1E10 as a float. How long have we been going? Almost 2 hours. 1.2, 6/5, 1E10, parse error. Ooh, I wonder if we're running out of room. Yeah, 1E8 is fine. I wonder if it's Rust max I32. One, two, three, 4, 5, 6, 7, 8, 9. So it looks like 1E10 is too big. I guess we should use, maybe we should use I64 then. One, two, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, out of range for I32. Okay. That's a bit sad. Parse v.into Okay, so parse is giving us an error. Not irrational. Set int string. So it looks like it's coming in here. Is there a try from? No. I see. Standard num parse int error. Oh, great. First, oh god, a spammer. Report? How do you... Okay. That's new. Alright, so this is too big for an i32. Should we just use i64? Do we need like big num? What are we in here? Value. What? Oh, there we go. Value. And this is called set int, okay. Set int string. Oh, this is where we were supposed to try, if this doesn't work, we're supposed to try big int string. Okay. Okay. I guess we can do that. So we'll go back to parse. So we'll try this. We'll delete this note. If let okay of I equals set big int string const s will return okay value big int of I. So this is our first big int. I didn't really want to do big ints. I guess how big can this go? What is a big int? A nat, which is a word. uint. Big dot int. What is Rust's largest? Rust big int. I guess we'll just use big int. So set big string, big int string. Let's try num big int from stir. Do we need to give it from stir radix s conf dot input base. Now this is supposed to be something like this. Result. Now this one is not an i32. This is a num big int. I mean, yeah, it's just since the num package is so easy to use, I'm happy to do it. Arguments of this function are incorrect. No variant for, yeah, okay. So we gotta add big int. big int, here's a num big int. No problem. What's the problem here? U32. Just like the other one. Result big int. Parse int error. We'll just take off that for now. Add the return type. There we go. Excellent. See how far we make it now. Ooh, 2 to 36. Oh, right. Yes. Gotta go back to parse. String. Where was I a second ago? Big int string. Set int string. No. The other one. The plain one. Parse error. What the heck? Not cool. Okay, we tried big int, but something went wrong in here. Oh, it's because it's 1E10. We're going to do the same thing we did down here. Yeah, I see it's actually more like this, right? Yep. Int set string. Let me base. So this now has to be boxed in error. So we'll try parsing this, and then we'll try to do this. From F64. Okay, or parse error. Takes one argument. Oh, F. No. No. What is this one called? Okay, so we don't actually look at the base here. This just assumes base 10. We're still supposed to use the base. Oh. No, I think we're supposed to be in... Oh, I messed this up. Hold on. This is not what we needed. Well, I guess I need to keep this. That's fine. We'll keep this. This is supposed to be like this. Assumes input base is 10. And now this, Clippy, come on, what's wrong here? Oh, now it's not static. I guess. For some reason this is not tick static. Okay. Alright. Well, Clippy, allow, Clippy, or fun call. Great. But yes, this does not actually fix our issue, because, oh, well, hold on. The issue is actually, yeah, this is actually not right. This should be set big rat from float string. Tried to make a rational from this and this. Yeah, this is wrong. This is supposed to look more like the Go version. Do they have big rationals? Big rational. Okay. Yeah, I kind of messed this one up. Let's back this up a little bit, because this is actually supposed to look like this. This one should be this. Okay. It's actually the big rat. Big rat. Big rat from float string. Yeah. So this should be big rat. Do they have normal rationals? Not a rational. Oh yeah, here we go. I guess we can just use... I think these should just all be big rat, maybe. Wait, what the heck? Rational. That's not even how we make rationals anymore, right? Uh-oh. New non-big int from B1 does that work? Okay, that works. Great. Tried to make a rational. Oh. Okay. Our ints might have to be big too. Oh, this is kind of sad. This is kind of sad. Yeah, we might just always use big ints. We might just always use big ints. What number is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh wait, no, I see what's going on. Rational. Oh, we can actually use... we can actually use that operator thing here, right? Wait, that's kind of interesting. So this doesn't really make ops. This is just, it's really just anything that does this double check. That's very interesting. So we can actually do this again, right? We can say make ops of how do we use it? We use it like this, left, right. No, we have to do int v1, int v2, left, right, rational, look at that. It looks kind of terrible, doesn't it? Well, hold on. Let's see. If we imported this, can I import this? Oops. I imported big. Come on. No module. Oh, I think this is some macro stuff. Okay, well, anyway. So, this one is going to be a big int. Ooh. Now it's not copy. This feels kind of stupid, but there. So we'll build the string up there. What? Big int. Let's debug this. It's a rational. Oh. Oh, that's right. Okay. So we got this. What is this? Three over. Oh, okay. It must be this. Wait, where's the slash? What is this? Oh, this is the rational. That's this. This must be... wait, 2 to the 64. is this 2 to the 64? Well, what is this? 3. What is going on? 17 over 15. Oh god, what's going on? Oh, this isn't the output. Oh, I'm a dummy. Hold on. Out. Out. 17 over 15, 1 over 9, 6 over 5. Oh no, what is this? Okay, something's going wrong. This is right. This is wrong. Oh my. Okay, yeah, hold on. We're messing this up somehow. So 1 over 9 is right. I think I should probably... Let's undo some stuff for a second. What did I do? Let's stash these. Hold up. Okay, we get 1/9, we get 6/5, and then we fail to parse this. Okay. So let's delete this. We'll do print line, trying big rat. Trying big rat. Okay, so something goes wrong in big rat. So we get 1E10, and then this is too big. Let's just make this a big rational, I think. Okay. This is going to be a big int. Are we just going to use big ints everywhere? We might. Let's just do that. We'll make all of our ints big ints. Big rat. This is a big rat. Ooh. Now that's a bit sad. You would kind of think that that would be implemented, right? All right. Let's just discard that again. Let's try this one more time. Try this. All right. We get a parse error because it's too big. So we got to go into here. And let's go see what they do. Big rat from float string. All right. The issue is basically that they always do the big rat. Not irrational. Okay, so we try setting an int string. I wonder if this is supposed to be... Let's try this. Print line, setting int string. And we want to try 1E10. Setting int string. Okay. Oh, it's because they're using N64s. Okay, we can do that. We'll make our int type an N64. That seems... That's kind of like a middle ground. Make this an N64. Okay. So these should be, let's replace, yeah, rational 32 with rational 64. Yep. Try that. Okay. This should return an I64. This should be I64. Make ops. Now pow. This is a ratio. Yeah, we're gonna have to do this. Try into unwrap. Because we want it to panic if something goes wrong. Okay. Now this is huge. Yeah. What size is that supposed to be? 1E100. Okay, it can handle it here as well. Go is just too magical, I guess. Not fair. Alright, take that one out. What now? Alright, yeah, you know what? We're just gonna restrict ourselves to small numbers for now. Alright, forget it. Pop the stash. Or I didn't mean to pop it, I meant to drop it. Alright, let's try that. Panicked at this. Don't care. That number is too big anyway. So Ivy, for now, skip that. Wait, what? Did I not save it? Wait, what did I delete? This one. Okay, so obviously we'll delete that one. Okay. This is too big. Does this one work? No, this one doesn't work. This is too big, this is too big, this is too big, this is too big. Okay, so something bad happened again. Oh, this is our... Okay. Although, I would kind of like to keep this one. I mean, 1E10 doesn't even seem like that big of a number. Yeah. All right. I think we should at least go to I64s. Let's undo this. Let's go look at value. But that's as far as I'm going. We're gonna make this an I64, and we'll make this a rational 64. Rational 32 with rational 64. Okay. And then let's replace I32 with I64. Yep. Okay. Now this dot try into dot unwrap. Okay. So now just 1E100 doesn't work, which is kind of crazy. Okay, now this one should work. Ooh. Oh, that's right. So this one's fine. we can take this. Actually, hold on. From ratio and int. Okay. I think this is probably just v1 over rational 64 from v2. Okay. Yeah, so this is supposed to be this over 3. And now we try to do the opposite. So I'll take this. Int 3. So this one's an int. This one's a rational. Yeah, okay. Rational of rational 64 new right from v1 over v2. Attempt to multiply with overflow. So we took out that one. This one's good. Okay. These are too big. These are too big. And we're back down to complex numbers. Okay. Make default int type 64 bits. Ignore big num tests. Okay. I'm happy enough with that. It's a bit of a compromise. We can handle this stuff, which is pretty reasonable. What's the biggest number we can handle? If we do 2, 64, that's a lot of digits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we can handle like 1 E20, thereabouts. I guess actually, hold on. Let's hold on a second. I think we can probably handle this. Let's try this. Let's go look at parse. Okay, I'm gonna take this node out. If let okay or equal 64 parts from stir. Let's see if we can just return it as a float. Okay. That'll work. So now if we go back over here, demo.iv. Okay. Attempt to multiply with overflow. I guess we have to do like a checked mul. So this is 2 * 64. Okay, so I think it's right here. Yeah. Okay, we might have to actually do this one manually. Whoops. P1I, J left, right. And then this is supposed to be this. Okay. And we can take the checked out for a second. And let's see, is this where we go wrong? Attempt to multiply with overflow. Okay. Let res equal this. And we'll go back to checked pal. Alright. If let okay res, then we'll do res. It's supposed to look like this. Else panic is supposed to be sum apparently. Oh, right. Panic. Too big. Okay, otherwise we'll return float of i.pal. I as f64.pal I j dot try into dot under. Okay, so we'll just fall back on floats when the numbers get big. Oh, inf. Okay. Which one gave us the inf? Okay. Yeah, we got inf. 1J3, 1J3. Okay. So we probably don't want to get infinity. Ooh, do we not have big floats? Two to the 6400. Is there like a num big float? No. Okay. Well, we've got to set the limit somewhere. Okay. Now this is over here. Great. Parse binary. Okay. So delete big num. No. All right. Bring back most of the big nums. Fall back to floats. Okay. There we go. So that's reasonable. I will delete this one because I don't like the infinity. Okay, and now we have to figure out the complex numbers. And this is causing... Oh, it's actually not this one. Oh, it's square root. Okay, that's great. This is actually a unary operator. Alright, let's go take a quick look at run. Because... Let's go look at prompt, actually. Prompt. Just... we'll just make the prompt empty again. Now, why is it printing this new line? If interactive. Whoops, not this one. Why is it printing like this? Oh, wait, I think I know. Do I know? iv.go, run file. It must be something about this. Interactive true, interactive false. Oh, interactive is supposed to be false. Oh, duh. That's why all this stuff is coming out. Holy moly. Okay. If interactive. Okay, so it's coming from here. Demo.iv. I changed the wrong one. Okay, there we go. Much more reasonable. I think we can... Whoops. Okay, we fixed that one. Handled exponentials. Now, I do want to actually... I did like the prompt. I like the idea of the prompt. But it's printing at the wrong time. Oh, well now it's actually 2. 2 plus 2. Okay, so it's like the opposite of the prompt. It should print the prompt first. If interactive, print the prompt. It's like we call run. Why is it not printing the prompt? Why is there no prompt? We call parser.run. Okay. Why is this not running the first time? It is. Is it buffered somehow? Conf.prompt. It's like the output's being buffered, maybe. fprint. Maybe we have to flush it? There we go. There we go. Okay, so we have to flush it. Alright, that's looking great. Now we actually have a prompt. Fantastic. 2 plus 2. Whoops. Great. Okay, so we're crashing now at square root. Run. No, back to demo.iv. Alright. Alright. Fix prompting and new lines on comments for non-interactive. Great. So we need square root. So I need to go to unary actually. Square root. Oh, whoops. Excellent. Unary. Binary. Great. Eval. Is this used? This should be used now, right? Oh, I see. We need to go look at, let's look for e.write.eval. So this looks like eval for binary. Let's look for unary eval. This one. Okay. What does inner? I'm guessing inner gives you the inner value. Okay. Binary eval is this. So unary will be this. Yep, this looks pretty much exactly. I really wish that iMenu would let me use the push up mark, I think is what it needs to do. We're looking for unary eval. And this we just call context.eval unary of unary.op. Oh, I guess it's supposed to be, we'll make it u just to be similar. So we got u.op, u.write.eval context. Return. Great. Excellent. Match self, use value star. Do we export this? Where's our macro? This only takes one argument, so it's not quite as involved. Alright, we got square root. So, to implement square root, we're going to use write. Okay, let's go look at this. Unary ops. Go to definition. Go down here. We're looking for square root. Square square root. Okay. Square root. Okay. So let's say match right. Okay, if it's a float, float f dot square root. Oh, it's supposed to return a value. Value float, f dot square root. Float int g. Oh. Integers don't have square roots. Oh, okay. Complex. Let's see, maybe we've done enough. The square root of a negative is imaginary. That's right. Okay. So I guess there's something else to check here. Greater than equal to 0. We can just do this directly. Great. Else, we will do something different. I guess we do value complex. So this is, we have just an integer, it's negative, we're trying to take its square root. We're going to return a complex that's int 0 and f dot abs, whoops, dot square root. Return. Oh, whoops. Int of this. What's the problem here? Oh. Great. Try that. Yay, we got 0j1. Now, what are we up to now? 0j1. Acos. Ooh. Go back to unary. Acos. Great. How do we do the Acos? Acos? Acos. Return Acos. Whoops. Of a complex number. How do we... No, how do we take... complex arc cosine? How do we do that? Let's see. So The imaginary part is not 0. Then we do this. New complex, 1, 0, complex square root. Oh my goodness. This is kind of the sad thing about the project right now, is that there's a bunch of stuff I don't really care about. I don't really care about complex numbers. I don't really care about the big nums. I just want to get down to the cool stuff. Let's skip this for now. Okay. Well, ACOs. But it's like, it seems like it should be easy enough to do. Does num have complex? I guess I have to do it down here. They do. Okay. So they have complex numbers. Let's go back to value. We're just going to use theirs. Complex. And we can get rid of this entirely. Yeah, we can just stop using constructors. Missing generics. What was it before? Before it was an int, right? Box value. It's 2 fields. Oops. No, that was right. Okay. Match. Right. Complex. C. Just returns value. Complex of C dot ACOS. Oh no. Ah, forget it. I have 64. So this is... So we're only doing complex numbers. Oops. What's the problem here? I typed the wrong letter. That's not what they got, is it? Demo out. Oh no, that's what we were supposed to get. 1.4. Okay, great. Plus 3i. Complex of 64. Okay, that looks fine. Great. This should not be one commit, but probably just gonna go for it. Start working on unary ops and use num complex floats. It's a little sad, I would say, that that we did that, but but it's all right. Yeah, unimplemented. What's up, Matthew? Are you asking if we should we use unimplemented instead? I think to do, let's see, I think unimplemented is supposed to be stuff that you're never going to implement. And I'm not going to say I'm never going to implement it. But yeah, so we do have a lot of to-dos. Maybe you're just remarking on how many to-dos there are. Let's see. I guess we can use projectile multi-occur. Well, that's in a div. Yeah, we have a lot of to-dos. This is to-do driven development after all. Okay. Now this is a bit disappointing because this doesn't look unterminated to me. Great. So that works. Okay. Oh, there we go. That was funny. That it just didn't do anything. Cargo run. What if I do this? Okay, so something's wrong with our quotes for sure. Let's go look for Lex quote, maybe. Lex quote. Self quote. Let's do print line trying to quote. Trying to quote, that's good. Let's go to Lex quote. Trying to quote again. So we're in here. Next enter. I wonder if this one's actually not supposed to be next enter. Scan. Lex quote. Yeah, this is okay. So quote. Debug quote. 39. All right, let's try char from quote. Okay, we got that. Okay. Oh yeah, because we backed up to put the quote back on. Then we pop the quote off. We should be getting to here. Okay, so we get here twice actually. With char from R. Okay, here with X, here with nothing. Okay. Switch L.next. So this is L.next. If it's a backslash. Oh, wait, what am I doing? We get the quote. We do 4. R. Oh, I shouldn't call this again. That's what's wrong. Yeah. No, we're just supposed to say switch switch on. This is our call to l.next. We are supposed to do this. Okay. This is switch l.next in effect. So this is our l.next. The first case is backslash. If it's backslash, then we're supposed to grab another one. If let sum r is l.next, enter. So this takes care, this is why I was doing that if let before. Because that is our if let sum and r not equal new line. We break otherwise we fall through, which means we return this. Oh, this breaks the switch. Okay. Does that work? Oh, yes. Excellent. But we don't know how to evaluate chars. I think this is just a value, actually. Yeah, you shouldn't actually evaluate that, right? What is this for? Where is this used? Eval string. Yeah, these are supposed to be value chars. Okay. Yeah, this is supposed to be, let's go back to value. Don't we have a char here? Delete this. Put this here. This should be value char. This can be a value, right? Expr value of value char. I guess probably have to do this now. Let's see. And I must misplace one of these. There. Okay. Perfect. Fix that. Non-exhaustive. Perfect. Char C. Right. W. Not that. There. Oh. Okay, that's fine. We should not. Yeah, so these should actually be. So this, for example, should be unimplemented. We shouldn't take the ACOS of that. Alright, what's not implemented now? Character. Oh, char is an operator. Oh, God. Okay. Yeah, okay, so that should be a string. We don't know how to handle strings yet. We also don't know how to handle vectors. That's what I really want to get to, is like vectors, arrays. It looks like they're coming up, though. Do we care? I guess we care. We have to define the char operator. Okay, let's see. Handle single chars. Yeah, now we have to go back to Unary. Let's see, we got a char operator. Char. Okay, self char. Okay, how do we implement this? Char validate. Do we have validate? Char. We are supposed to return if let sum, no, not sum, char c equals right, else panic char called with so we have to take something. Do I have? I feel like I have something called validate. Apparently not. Okay, validate. Okay. Actually, what is, so we're just supposed to like cast it as a character. I guess we're supposed to say char from C, I don't know. Oh, we can only get it from U8. I guess we want this then. This is a bit circular, isn't it? Yeah. Bad number syntax. Where does that come from, actually? Oh. Yeah, we were supposed to parse that somewhere else. Accept number. This is where we were supposed to do this, I think. Let's see. Somewhere. Scan number. Probably it's in scan then. Scan number. In here. Okay, so we do come in here. Context read base. If base 0, okay, let's put this here. Yeah, we're in here. Bad number syntax. Debug digits. It looks like something is wrong here. Digits. Okay, so it did work. But this must be wrong. Valid. Oh, I think the issue is self.accept scan number. What is self here? Scanner. What are we looping over? Self.next enter debug char from C. Yeah, 0. Okay, 6, 1. What's the problem here? So we got 6, 1 space. Which I guess... Oh, I guess that's fine, actually. Wait, is there really a space there? Oh, yeah, because of this. Okay, 0x. So we're getting 61. That should be fine. Consumes a run of runes. Break. And we're supposed to back up. Okay, so that seems fine. 0x. Accept run of digits. It's supposed to be 61. Now, where do we actually set the... Shouldn't we set the base somewhere here? Base. Okay, so scan number is fine. It looks like scan number is fine. Where does this get called from? I mean, I guess this is where we're coming from, right? Accept number. For some reason... Oh, no, it's not here. Oh, maybe it's here? No. Add number syntax. Oh, it's here. But we shouldn't end up here. We should just... Why isn't this one working? How does this work? Where is accept number called from? It's supposed to be in lex complex. Okay. Lex complex. Okay. At lex complex. Great. So we're at lex complex. We call accept number. Trying scan number. Returning. We're kind of doing like bisection, I guess. Okay, so we don't make it to return. Trying real part. Okay, we don't make it there either. It looks like we're returning here. But we're not returning here. I guess, are we returning here? Okay, we're returning here. Okay. So we're trying scan number. which is fine. That's right. Like, we scan the number, and it's not slash. So we should go back to lex any. Yeah, okay, so we're back in lex any. Lex any. Now, no, this can't be right. We're at lex complex. This is so complicated. Okay, so we accept number. After accept number. It's true. Okay, it's true. There's no J. After accept number 2. Ooh. Okay. If it doesn't accept J, we're supposed to emit. Oh, maybe it's in emit. Okay. It's gonna be right here. Returning. Returning. Okay, so this is where we return, right here. Now, in here, we need to handle the number. How do we parse this number? I mean, clearly this is what's going wrong. So we're getting a token number, and for some reason I'm doing big rat from float string. I guess set int string should just work, right? But let's see, rust parse hex number. I think this is the problem. I'm guessing. No, it seems like that should work. Oh, it has the wrong base. Oh. Wait, is that right? Alright, let's just debug S here. That doesn't feel like it should compile. Okay, 0x61. Alright. If base is 0, base is 10. If s dot contains, if s dot starts with 0x, base is 16. Let's try that. No. You're kidding me. We should try this first, right? So we're in here. Something goes wrong. Something goes wrong here. Base is 16. Why can I not do this? Oh, we have to strim. Oh, I should have read the rest of the answer. Strip prefix. Yes. Char called with 97. Oh. Okay. if let char c, then I return char c. If let int c, return char from. Okay, well then I guess we'll do char from c dot try into. So we have an I64. We're going to try into unwrap it as a U8. Type annotation. Oh, okay. Try into U8. What? I see. Let great. So we got an A? Is that the right answer? Yes. Yes, it's right. It's right. Now this is wrong. Try from int error. So now we're having trouble with C, which is okay. How do we make a Unicode? From... Oh, you can do it from U32. 32. C dot try into dot unwrap. Let's try that. Oh. Looks like I have to unwrap again. Yay! We got a poop emoji. Matthew says you could use a match statement on the first two characters. Is that back over here? What were we doing? I guess I can look at the diff. This one starts with hex parsing. Can I do that? Then it's easy. Oh, I see. Yeah, that's a good point. I think for now I'll just leave it like this. How would I, let's see, how would I do that? Match S. I guess I'll have to check. Can I do that? Match S. Up to 2. Oh, whoops. No, we need to borrow here. like that. Does that? I guess that's a bit better. I guess now we need to check if s.length is if s.length less than 2, then we also need to return this. Just trying to decide if this is nicer. I guess maybe we should do if s.length greater than equal to, we'll come into this match, and then we can return from inside the match. And then at the end, we do this. Whoops. Oh. Okay. Now Clippy looks mad at me. You seem to be trying to use match for an equality check. Consider using if. Yeah, I mean that's fair right now, but I guess what is it for octal? Oh, so if it's just a leading 0. Okay. Yeah, I'm not sure about this. Did I do it? So 0, 0. Oh, is that how Rust does it? If that's how Rust does it, then we're fine. 0, 0. Oh, okay, good. Because in the... Is that right? Yeah, 0, 0. Okay, okay, good call, good call. Yeah, because he said just the leading 0, I guess, is how they do it in C. So if it's 0, 0, then that's fine. That's perfect. We'll do that then. 0, 0. We'll strip the prefix and base 8. Okay. There we go. Yeah. Yeah, if it couldn't be, if they were all at least 2 characters, it would be really nice. 0. Ooh, bad number syntax. 0x. Okay, that's fine. Did I mess something up here? 0, 0. Did I forget to save? Oh, I wonder if this is hitting something else. Maybe we made this assumption somewhere else. Okay. What? Please. I think maybe there's somewhere else. Yeah, like in accept number we might. Or wait. It was earlier when I was doing this. Let's see. Base. Accept number. It was somewhere with this. I think we're not accepting it somewhere else at the moment. Accept number. Accept. Scan number. Digits. Okay, yep. Accept octal for 0. Let's do octal for 0. 0 or 0 O or 0 O. Okay. If base is 0 and self dot accept OO. Okay. Let's see if that works. No. 0 O. Okay. Base is 0. Oh, did I get it? Well, okay. 0 O. Did I type the wrong thing? 0 O. Zero X 0x5. Oh, do I need... Oh, that might be right. Okay, hold on. Now we're back to not accepting this. Yeah, maybe we need that. Let me try this. Whoa. Okay, that was fine. Okay. If base is 0... And, oh, yeah, yep, you're right. You're right. And self dot accept. So I guess we want it to contain a 0. Yes, good call. Accept, oh. Okay, let's try that. 0.05. Yes, perfect. Okay, great. Now we actually support octal as well. Thank you. Very nice call on that. Let's see. Okay, are we actually down to variables? So what did we fix here? We added the char operator. Okay. Add char operator and handle hex octal numbers. Great. So we're down to, oh, yes. Oh, no. Now we're down to code. Okay. So that's fine. Let's add that operator, and then I'm probably going to call it for today. Because tomorrow, we'll finally get down to vectors. Or probably not tomorrow, actually, since I'll be back to work next week. But we're to vectors. That's great. This is one of the... this is probably the big thing. Vectors and matrices. All right, let's implement code real quick. Unary code. Code. Okay. So we want to call code with a character. Okay. We will do c dot into. Let's see, return. I guess it's supposed to be an int. F32, the trait bound I64 from char. Okay, so we want I64 from I guess we want like C as UA dot into maybe? Yay. Oh. Index out of bounds. The length is 3. Oh no. Oh no. We're doing Unicode stuff. Okay. Oh no. Thread main panic index out of bounds. Wait, what? What are we doing here? Code. Oh, I think we can't even like handle this emoji. Whoops. Even my terminal, I think, is having some trouble. Yeah, bytes. All right. Well. All right. I think I might go ahead and call it there. That is harder than I thought. I guess let's see if code works for code. See. Okay, so it works for normal stuff. We just need to handle Unicode characters. Okay. Handle code operator for ASCII to do Unicode. Yeah. All right, so that'll be the first thing we'll work on next time. I'm not sure when that will be. It might be next weekend. I'm also going to start doing the advent of code puzzles when they come out in just a few days. So probably I will see you all doing that before I get back to algae. But thank you, especially to Matthew again for all the help. And I'll see you guys next time. I'll actually push these changes today, so you can go look at them on GitHub if you want. But thanks. I'll see you guys next time.